Welcome to this lesson on inequalities. Well, first of all, an inequality is a mathematical statement which uses the signs less than or less than equal to, greater than or equal to. And some examples of these are, for example, 2 is less than 6, 5 is greater than or equal to minus 1, 3x plus 1 is less than or equal to 7. Right, so those are some of the mathematical statements, and basically using those four signs only. We can represent inequalities on a number line. So this is a number line over here as an example, and it's on the x-axis. So inequalities can be illustrated by using a number line to represent infinite number of possibilities to the answers. The important thing here is to use an open circle, so a circle that is open like that with the arrow on the end, for any of those signs that have less than or greater than. However, when we used closed circles, we represent the less than and equal to or greater than and equal to, and this is an example of a closed sign, so I'll just color it in. Not doing a very good job, but coloring it in and then putting a line with an arrow on the end of it. So that is actually called a closed circle, and that is an open circle. Right, well, let's have a go at putting this on the number line. So x is greater than 3. Now remember, because we're using the greater than sign, we actually use a open circle. Okay, so somewhere on this number line over here, we need to have x is greater than 3. So where is 3 at this stage? Well, 3 is over here. So what we do is we draw a circle on 3, and it's greater than 3, and we put our arrow. So what would we do if it was x is less than 3? Well, exactly the same. I'm going to draw it on the bottom of the x-axis, but normally we'd actually draw it in exactly the same place. But I'm just going to do it underneath for the moment. So we could draw it as 3, and it's an open circle because we are using the less than sign, and we draw our arrow like that, and that represents x is less than 3, starting at 3 with an open circle, and it is any value that is anywhere on this number line less than 3. Therefore, an infinite number of answers to that particular question. Alright, well, what about this one? X is greater than or equal to 2. Well, what we need now is to find where 2 is, and 2 is over there, and we need a closed circle, so we're going to color it in. Alright, and we're going to put our arrow going to the right. That represents that x is greater than or equal to 2. Therefore, it is any value greater than or equal to 2 on the number line going in this direction, the direction of the arrow. And exactly the same will happen for this value down here. X is less than or equal to 2. So doing it again at the bottom, we have a closed circle, alright, and our arrow goes this way, and that represents that x is less than or equal to 2, starting at 2, so therefore the answer to that is any infinite answer less than or equal to 2. Alright, here's a little challenge for you. See if you can graph this one. Minus 2 is less than x, which is less than or equal to 3. See if you can plot it on the number line over here. Put the video on pause and come back when you're ready. Well, how did you go? Well, firstly, I'm going to look at this portion of the equation, and then I'm going to look at this portion of the equation. So minus 2 is less than x. The less than means I need to have an open circle, so less than 2 is going to be over there. I'm then going to look at x is less than or equal to 3. I therefore have a closed circle, so I'm going to put my closed circle over there. And when I look at my equation, minus 2 is less than x, which is less than or equal to 3. My answer therefore has to be somewhere in this line over here. So I can just join up those two circles, one open and one closed, and therefore my answer has to be somewhere in the middle of those two. And that's how you graph it. Well, the next thing we're going to look at is solving inequalities. Pretty much we solve inequalities exactly the same way as we would solve any type of linear equation. And what we need to do is keep our xy itself and obviously move our whole numbers to the other side of this particular sign, which in this case is less than. Alright, so let's do that. So we're going to have x. Alright, we got that one, and we're going to add our 3 because our 3 is coming across from this side over here to this side over here. So we're going to add 3 to the side, making this 0, and so therefore we've got to add 3 to the side. Therefore x is less than 10, and therefore solving this particular inequality. Well, how about this particular inequality? Why don't you put the video on pause and give this one a go, and when you're ready come back and see if you got it right. Alright, well here we go. So this will be minus 2x is greater than, and we're going to have 3 subtract 5. So minus 2x is greater than minus 2. Therefore we're going to divide this side by minus 2 so we can cancel them out, and therefore this side we have to divide by minus 2 as well. So that cancels with that cancels with that, giving us x is greater than 1, because if we go minus 2 divided into minus 2, it goes in once. And we have solved that inequality. Well done. Alright, well here's another one for you. Put the video on pause and see if you can solve this one, and come back when you're ready. Alrighty, well I'm going to leave d over 4 on the side, and then I'm going to move my minus 3 over to the other side. So it'll be minus 11, add 3. Alrighty, so I'll have d over 4 is greater than or equal to, what's this value over here? This is going to be negative 8. Okay, therefore I need to multiply this side by 4, and I've got to obviously multiply that side by 4 because I want to get rid of the divide by 4 here. Alright, so we've got d all by itself over here, and I would therefore have 8 multiplied by 4 giving me minus 32, and that would be my answer. Alright, one last one for you to solve. We have a's on this side and a's on this side, whole numbers this side, whole numbers that side. See what you can do. See if you can solve this one. Put the video on pause and come back when you're ready. Okay, well this time round I'm actually going to move my 2a from the left hand side to the right hand side, and the reason I'm doing that is I have a greater value on my right hand side than I do on my left hand side. So I'm going to leave my 7 on this side, subtract 3 is less than or equal to, and I'm going to have 6a take away 2a. Right, well 7 take away 3 gives me 4 is less than or equal to, what is 6a take away 2a gives me 4a. Therefore 1 is less than or equal to a. And how did I get that? Well, I simply divided by 4 on this side, therefore this side needs to be divided by 4, so that would be 4 divided by 4 gives me 1, and obviously 4a over 4, the 4's cancel each other out, giving me my a. And we always write our pronumeral on the left hand side, therefore we have to go a, and then we reverse our sign, equals 1. Therefore a is greater than or equal to 1, and that's our answer. And just to show you, if you wanted to keep your 2a on the left hand side, you're moving your 6a across and keeping your 3 on the one side and moving your 7 across this way. That you could do it this way if you wanted to. You'd actually end up having to do exactly what I did over here by reversing the signs anyway, but you would have negative a is less than or equal to negative 1, and when we get rid of our negatives we also have to reverse our signs, therefore a is greater than or equal to 1. Exactly the same answer as this one over here. Alright, well that's the end of inequalities. Well done.